there. All right, so let's look at some of the problems that you run across in this lesson in the Introduction to Problem Solving. So some of the problems that you'll come across will have it broken down into steps for you. And actually your answer is each part of those steps, not just your final answer. So it kind of forces you to kind of think through the parts of solving this problem. In this one, it says some number minus 2 is equal to the product of the number and 11. What is the number? All right, so let's walk through the process. All of these words in this expression can turn into some sort of mathematical operation. So the first part of the equation says some number minus 2. Well, this number that we're looking for, when it says some number, that's the number that they're asking for. So you assign it a variable. Sometimes they'll tell you what they want you to use for a variable. I'm just going to use x because this problem doesn't specify. So it's some number, well, that'd be an x minus 2. So that's x minus 2. All right, so now we've finished out this part. Okay, is always going to tell you to put in your equal sign. So I know that I'm going to put an equal sign later for that, or sometimes it'll even use the word equal, like this one does, but sometimes it doesn't. Okay, so then we work with the product of a number and 11. So the word product, you have to remember, means you're going to multiply two things. The sum tells you to add, the difference tells you to subtract, the product is the result after you multiply. If it uses the word quotient, that implies division. So it's going to be the product of the next two things they talk about. So it's the product of the number, we know that that's x, and 11. So I know that it's an x times 11. Now I could write that x times 11, but typically the way that you're going to see that is the number goes in front of the variable, and we probably wouldn't even bother writing the dot. We would just write it 11x. All right, so what we have then, step 3 tells us just to write out the equation, and this one we don't even have to solve it. We're just going to write out the equation. So let's just do it left to right. It's some number minus 2. That's what we found here. So x minus 2 is equal to, so that tells us to put our equal sign in there. And then the second part of it is the product of a number and 11. So that's my 11x. And so I'm done. All I have to do is type in that expression and I've got it. All right, that one's done. All right, here's a problem that's not broken down into parts. It just gives you the information and asks for the final answer. Now this particular problem I look at and I feel like I could set this up different ways. I'm just going to choose a method. You may choose a different method, but this is what I would do. So it says Sarah's text messaging plan charges 10 cents for each message over 650. In addition to an $11 base charge. Okay, so she's got this flat fee of $11, but she only gets 650 text messages, and then after that she's having to pay. Okay, all right. It says at the end of the month she owes $24.40 for text messaging. How many text messages did she send that month? Okay, that right there, I guess I'm going to make my variable. How many text messages did she send that month? I'm going to call that x. X is the number of text messages. Okay, so let's work on setting up our equation. Her plan charges 10 cents for each message over 650. Okay, so she's going to have to pay 10 cents. I'm going to write that 0.10 like that, 10 cents. For each message, so I'm going to take 10 cents times all of her text messages. But here's the deal. She gets 650 of them free. She's only paying the 10 cents on the things above and beyond 650. So what I'm going to do is I'm going to start off with x, because this is the total number that she sent. But I'm going to subtract out the 650 texts that she gets for free. And then this will represent the leftover, or the extras, I guess, the amount over the 650. And those are the ones that are going to have to get multiplied by 10 cents. All right, so that's my first part. That's the 10 cents for each message over 650. In addition to, that'd be a clue I should be adding, to an $11 base charge. So no matter how many texts she has, she's going to have to pay this $11. So I'm going to add $11 to that. So that right there is kind of her plan. And then it says she owes $24.40 at the end of October. So for 1 month, this is her monthly plan, this has to end up equaling $24.40. There it is. That's your equation. X is going to be the number of texts. If we can solve this for X, we'll have the answer to the equation. So what I would probably do first, I would go ahead and distribute the 10 cents. So when you distribute, you're going to have 10 cents times X, and then 10 cents times 650 is going to end up being minus 65. All right. Now, when I look at the left side of this equation, I have a couple like terms. This term has an X. The first term has an X, but this one and this one are like terms. So let's go ahead and combine those. So now it's going to be 0.10x. A negative 65 with a positive 11 is going to end up giving you a negative 54 equals 24.40. And remember, we're just trying to isolate the X, so I keep moving stuff away. My next step would be to add the 54. And I can add the decimals if I want. I don't have to. Either way, 0.10x, 54's cancel. It's going to equal, that looks like that's going to get me a $78.40. And then to get that X by itself, I'm going to have to divide by 0.10. And then you can go to your calculator, $78.40 divided by 10 cents ends up being 784. Now remember what X represented. X was the number of text messages here. And so that's what we just found. She had 784 text messages that month. Now she didn't have to pay for all of them. Remember, she gets 650 free, but the question said how many text messages did she send that month? So that includes all of them. So my final answer on that is going to be 784 text messages. All right, the last type of problem that we're going to go over is fairly common. You'll come across several of these on your homework, and they're kind of a fan favorite of textbooks to set up these consecutive integer function or equations. All right, so first of all, we need to understand what consecutive integers are. Well, integers I always think of are anything on a number line. So it's going to be a 1, 2, 3, 4, no decimals in there, but it can also be negative. So it might be a -1, -2, -3, -4. Though on these problems, they typically use very large numbers, so that kind of deter you from just trying to do it in your head real quick. So let's look at what consecutive integers are. Consecutive integers would be something like 1, 2, 3, 4. Consecutive even integers would more be like 2, 4, 6, 8, and so forth. Consecutive odd would be 1, 3, 5, 7, and so forth. All right, so when they're going to say, what's the sum of 3 consecutive integers or something like that? Okay, well, when I start looking at this, if I'm talking about multiple integers, typically I'm going to call the first one x. So this would be like 1 would be x. And then what you have to do is you have to notice the pattern. For each new integer, it looks like it's just going up by 1. So my first one would be x. My next one would be x plus 1, because it would just go up 1. The one after that, if I'm referencing back to the original, it would be an x plus 2, because it's 2 bigger than the original. And you could go x plus 3, x plus 4, x plus 5, just depends on how many integers they're talking about. So when they talk about consecutive integers, you're going to use an x, and then an x plus 1, and the one after that would be x plus 2, and after that would be x plus 3, and so forth, for however many integers they want you to use. when they look at consecutive even integers. If you'll look at the pattern on this one, it is not increasing by 1 each time. This time it's going up by 2's. So the 2 in this example I would just call x, that's my original. And then if the pattern is to increase it by 2, the next integer would be an x plus 2. The one after that, that means you're going from this 2 and you're going to be increasing it by 2 and then by another 2. So the next one would be called x plus 4. And if you were to do it again, so there I'm increasing it by 2, I'm increasing it by another 2, by another 2. So that ends up being x, next one is x plus 2, the next one after that would be an x plus 4, and then an x plus 6, and so forth for however many integers they want. All right, so now the next one, this is the tricky one. It's very, very tempting to say, oh, consecutive odd integers. Well, then that would be x and x plus 1 and x plus 3 and x plus 5 and so forth because they're consecutive odd, right? Okay, that's actually not the case. That is not what that would be. Let's look at why. Your first one is x. Yep, I'll give you that. But look at what the pattern is. You're actually going up by 2's still. So this would be the first one plus 2 would get you to 3. And to get to the next number, I'd have to increase it by another 2 and increase it by another 2. So whether you're going up by evens or by odds, you're still, the pattern is that you have to add 2 each time. And then an x plus 4 and so forth. So really, whether it's doing consecutive even or consecutive odd, this is going to be the pattern that you want to use. If it just asks for consecutive integers, then this is the pattern that you're going to want to use. You really have to pay attention to whether they use that word even or odd in there. Don't miss that. That'd be an important thing to distinguish between. All right, so with that being said, let's try one. All right, this one says the sum of 3 consecutive odd integers is 345. Find the 3 integers. Now, I actually did one of the easier ones because this one is a positive, this 345. A lot of times those are negative, and it makes that a little bit trickier. But here we go. Sum of 3 consecutive odd integers. So my first integer is going to be an x plus, and then my next integer, since it's a consecutive odd, it's going to go up by 2's. So my next one is an x plus 2. And then the third equation, or I'm sorry, the third integer is going to be an x plus 4. And I'm adding these because it used the word the sum. The sum of those 3 consecutive odd integers means equals 345. Okay, so now let's see if we can solve this. I put those in parentheses to help distinguish the 3 separate integers, but if you're adding, you don't really need them. And so you'll see the software does this too. They write that, but then they come right back and they get rid of the parentheses. And then you're looking to solve for x. So on the left side of this equation, I'm going to look for any like terms that I have, and I've got a bunch. I've got all these x's that can combine, and then I got this 2 and this 4 that can combine. So an x plus an x plus an x is going to get me a 3x. And the 2 and the 4 is going to get me a plus 6. And now you're down to just a 2-step equation. Let's subtract the 6 to the other side. So 3x is equal to 339. Divide both sides by 3. So x is going to be 113. Now notice there's 3 answers here, so you got to pay attention to what you just found. I found x. X, if you'll recall, was my first integer. So I know that my first answer is 113. But they want all 3 of them. So now my next one is this one. And it's a 113 plus 2. So that would be 115. All right, and then the last one is my 113 plus 4. So that'd be 117. And those are my answers. Those are my consecutive integers. Now, let's talk real briefly. We'd be done with this problem, but let's talk briefly about what if that was a negative. So, real quick, let's just pretend for a second that my x ended up being a negative number, which will happen if this 345 was negative. But let's just pretend, oh, I got an answer, x is equal to negative 113. What would that do? Well, be really careful when you go adding that. That's your first one, yes. Now think about what happens if you add 2 to that. That is not going to end up being negative 115. You'd have a negative 113 plus 2. Those are opposite signs. That really is going to end up being a negative 111. So you'd have this as your first answer, negative 113. Then you'd have a negative 111. And then your third one would be a negative 113 plus the 4, which again, the signs are different. So that actually would end up being negative 109 for that. So if it's negative, be careful with those. All right, that's all I've got for you. Hope this helps. Good luck.